In this video, we will be looking at how to factor perfect square trinomials. But before we do that, we're going to look at a little warm-up where we factor a perfect square trinomial using decomposition. Because any trinomial can be factored with decomposition, but we have some shortcuts for simple trinomials and perfect square trinomials. So let's get started. First thing we're going to do is find the product. So 4 times 9 is 36, and our sum will be the middle term, which is negative 12. So because the product is positive, we know that both numbers should be negative, so that way the sum will be negative as well. Having two positive numbers wouldn't make sense because then they wouldn't add up to that negative 12. So our magic numbers end up being both negative 6. So I will decompose that middle term into minus 6x, minus 6x, and then plus 9 at the end. After we decompose, we're going to pair up our terms and grab that common factor from each. For 4x squared minus 6x, 4 and 6 can be divided by 2, and they both have an x in common. For negative 6x and 9, they can both be divided by 3 with no variable. And since the first term in that pair is negative, we will take out a negative 3. When we divide out 2x from the first pair, 4x squared divided by 2x is 2x. Negative 6x divided by 2x is negative 3. When I divide out the negative 3, I'm left with negative 6x divided by negative 3, which is positive 2x, and 9 divided by negative 3, which is negative 3. Our brackets match, so that's a good sign. So here's the common bracket, and then the leftover bracket comes from those common factors. And you will notice that our brackets are identical. So we can write our bracket 2 times, or we could have written it as the bracket to the power of 2. Now some observations I want you to make. First of all, our final factored form, the brackets were identical. But also, if you look at your starting trinomial, what is special about it? Your outside terms, so the 4x squared and the 9, they are both perfect squares. 4 and 9 can be square rooted, and remember, an even exponent for a variable can be square rooted as well. Now the middle term does give us something else that's important. If you notice, the middle term was negative, and the sign in our brackets was negative. And there is actually a little check that involves that middle term. So if I were to take this 2x minus 3 squared and do a FOIL to get this back, I just want to show you what happens. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is positive 9. Notice your middle two terms are identical, and our magic numbers were identical. So they're the same number 2 times. Now how did we get that negative 6x? By multiplying the 2x and the negative 3. So this actually creates a little check for us. When you see this potential perfect square trinomial, if the middle term had been anything but a 12x, you would have had to do decomposition. So our check is to multiply the two terms in our brackets, so the 2x and the negative 3. And because that negative 6x occurs twice when you FOIL, we double this answer, so times 2. So 2x times negative 3 is negative 6x, and then when I double that, I get the negative 12x, which is my middle term. So if that middle term had been, let's say 10x, this would not have been a perfect square trinomial. We would erase it and we'd have to do full-on decomposition. All right, so let's see how to do this shortcut. But before we do that, how do we recognize it? The outside terms are perfect squares. And we will have to do a check as well. But let's see how we factor this. So let's look. We have a trinomial. The outside terms are square rootable. So all we're going to do, because we recognize it as a perfect square, we can just write a bracket to the power of 2. Or you can just open up 2 brackets and you're going to fill them in with the exact same terms. The square root of 9x squared is 3x, and the square root of 25 is 5. And because the middle term is positive, you're going to write plus. Now, some people say, but where did the middle term go? It didn't go anywhere. If you were to FOIL this, like write the bracket out twice and do distributive property, it would come back. But we are going to use that middle term for a check. If we were to FOIL this, and you can do a check by doing a full-on FOIL. It's just not very efficient. What we're looking for is when you do the outsides and the insides, which is 3x times 5, you get this term 2 times. So that's why I multiply by 2 at the end. 3x times 5 is 15x. So that means in the middle you'd have 15x plus 15x. So doubling 15x is 30x, and that's exactly what we get in the middle. So this is a perfect square trinomial. If this didn't work, I would erase what I did as my shortcut and I would go on to a full-on decomposition. But this is a lot more efficient. And another reason you might want to recognize perfect square trinomials is because sometimes perfect squares are really large and it might be annoying to try to do a product and sum when the numbers are very high. All right, let's go to the next one. So 4x squared minus 28xy plus 49y squared. I recognize this as a perfect square trinomial because of the 4x squared and 49y squared. So I'm going to put my bracket to the power of 2. The square root of 4x squared is 2x. The square root of 49y squared is 7y. My middle term is subtraction, so I'm going to put minus. And then I'm going to show a check, because what if this was a trick and it wasn't actually a perfect square trinomial? So when I do FOIL, I know at some point I'm going to multiply 2x and negative 7y. And because that term pops up 2 times, I times it by 2. So 2x times negative 7y is negative 14xy. And when we double it, negative 28xy. So yay. Okay, the next one. The next one, the numbers are quite small, so you might have automatically gone to decomposition. Not the end of the world, but 9 and 1 are square rootable. So I'm thinking this is going to be a perfect square trinomial. The square root of 9x squared is 3x. The square root of 1 is 1. The middle sign is negative. And here it is. My check, which you can also do in your head after a while. 3x times negative 1. Double it, because it pops up twice when you do distribution. 3x times negative 1 is negative 3x. When I double it, negative 6x. That's perfect. All right, for C, we have a few little problems here. The first problem is that the first term is negative, which right away tells you I need to do a common factor, even if it's just negative 1. But also, if you look at the 2 and the 32, they're not perfect squares. So there must be more of a common factor here. And we actually have a GCF of negative 2. So when I factor out negative 2, we're going to be left with m squared. Negative 16m divided by negative 2 is positive 8m. And negative 32 divided by negative 2 is positive 16. Now this last one you can actually see as a simple trinomial, not just a perfect square trinomial. Either way would work, but m squared is square rootable, and so is the 16. So we're going to have negative 2. The square root of m squared is m. The square root of 16 is 4. Put addition, because the middle term was positive, and then raise it to the power of 2. And if I were to do a check, I'd multiply my 2 terms and then double it. So 4m times 2 is 8m. It matches the middle term in the perfect square trinomial, so that's good. Now, like I said, you could have seen this as a simple trinomial as well. The product had to be 16, the sum had to be 8. Your magic numbers would both be positive 4. And if you don't like writing the bracket to the power of 2, you can just write the bracket out 2 times, and that's perfectly fine. Now, when it comes to trinomials, like I said, there are 2 shortcuts. We've already seen the simple trinomials, but let's just recap them anyway so that you see both shortcuts for the two special trinomials. So for perfect square trinomials, your outsides were perfect squares. For a simple trinomial, the coefficient of x squared is 1. If it's not 1, it's either the perfect square trinomial or, more likely, it's just a complex trinomial that you have to do decomposition for. So if I have x squared minus 7x plus 10, this is not complex because there's no number in front of x squared. It's not perfect because 10 isn't square rootable. So my product is the 10, my sum is the negative 7. My magic numbers would be negative 5 and negative 2, because if I multiply them, I get 10. If I add them up, I get negative 7. So x minus 5, x minus 2. A lot faster than doing decomposition. But you have to recognize the shortcut. For the next one, our product is 24. Our sum is 11. Both of our numbers should be positive here. So 8 times 3 is 24, and 8 plus 3 is 11. So x plus 8, x plus 3. And finally, the next one, this is not simple because there's a negative 2 in front. Even if I didn't recognize that there was a common factor of 2 here, you should right away know that you have to factor out that negative because you cannot have your first term negative. So, but there is more than just a negative. We're going to factor out a negative 2. And when we divide negative 2x squared by negative 2, we get x squared. 4x divided by negative 2 is negative 2x, and 48 divided by 2 is negative 24. Now we have a perfect square trinomial. So we're looking for a product of negative 24, which means we need a positive and a negative number, and a sum of negative 2. So our magic numbers will be negative 6 and 4. The 6 is the negative one, so that the sum does become negative in the end. Write your common factor, and then your two brackets, x minus 6 and x plus 4. So those are your two trinomial shortcuts. Decomposition will always work for you for a trinomial, but sometimes there is a quicker method. But when in doubt, if you're not sure, if you forget how to do the simple trinomial or you forget how to do a perfect square trinomial, do decomposition. That's guaranteed to work, but simple trinomial will not work for a complex. So that's it for the perfect square trinomial and the little add-on and refresher of simple trinomials.